Hi, everyone. My name is Vandy, and I'm a product manager at Google. Today, I'm excited to share with you how you can set the right guardrails from the get go to ensure security and compliance using organization policies. And joining me is Alex Pearson, who is a lead enterprise cloud architect at HSBC, an organization with about 250,000 employees. And Alex will walk us through HSBC's journey in the cloud, how they think about security, and how organization policies are a critical part of their journey. So, when you're moving resources to the cloud and building in the cloud, you want to ensure that your development teams can move fast without security being a blocker. To do this, you need to set guardrails that allow development teams to innovate freely and securely within those protective boundaries. Being able to specify the types of services that are allowed or requirements around which images can be used when creating VMs are the types of guardrails customers want to enforce for consistency, cost, security, and compliance. And we have organization policies to be able to do just that. GCP has over 60 constraints that you can leverage to govern your organization. Let's take a look at how security admins think about this. So, if you're a security professional like Taylor here, you're thinking about what organization policies to enforce so you can set restrictions on which resource configurations are allowed. As Taylor thinks about her compliance requirements, she's thinking about restricting which regions her developers can create resources in and which services they can use. She also wants to ensure there isn't any public access to resources in GCP and ensure that managing service accounts keys don't get so unwieldy and land in public repositories. And it's really important to Taylor that these constraints are set early on before too many developers and resources are on the platform. Luckily for Taylor, organization policies come in handy for being able to set these types of constraints. You can access the list of available organization policy constraints in the IAM and admin section. A constraint is a particular type of restriction against a list of Google Cloud services and resources. This constraint is then applied to a resource hierarchy node as an organization policy, which implements the rules defined in the constraints. Customers leverage these constraints no matter where they are in their cloud journey. We encourage you to check out these constraints to see how you can enforce them to meet your business requirements. Some policies we highly recommend are things like disabled service account keys creation and domain restricted sharing, which prevents users from outside of your organization from accessing resources. Now, back to Taylor's need to enforce some constraints around which services can be used by her developers. In our most recent update, we launched a new constraint in private preview called Service Usage Restriction. This is a governance policy that allows administrators to control which GCP service can be used within their resource hierarchy. Service usage restriction policies are organization policy constraints which can be set at the organization, folder, or project level. So to set a policy like this, click Edit at the top of the page, then Customize. And in custom values, add the service that you want to allow or block to the list. So, for example, you can allow compute.googleapis.com. And if you want to add more services, you can just click New Policy Value. To enforce the policy, just click Save. And now Taylor can enforce other policies in a very similar fashion to ensure that the right guardrails will protect her infrastructure. Another new capability within GCP is tags. GCP's resource hierarchy is a great way to organize your resources into a tree structure. While the hierarchy is useful to manage resources at scale, it is limited to only a few business dimensions, such as organization structure, cost centers, and so forth. So if you use tags to organize your resources around other dimensions, we can now make it easy for you to do conditional enforcement of organization policies. Security engineers like Taylor are also starting to use tags to progressively enforce policies across their regions to minimize fallout from a big bang rollout. In this example, we want to enforce the disabling of service account key creation for projects in a specific region without affecting other regions. We created tags specifying those regions, applied them to the relevant resources. Now we're ready to enforce the disabling of service account key creation. While it was not previously enforced in the organization, we can start to enforce it across a subset of organization based on the tag specified. Find the policy, hit edit, select add rule, turn on enforcement, and then here, just add the condition that you want to add to enforce the policy for resources with a specific tag. Specify the tag, and now, just like that, we are enforcing this policy for just the resources with the tag US East 1. We hope that you will leverage these new capabilities and constraints to meet your business requirements. And with feedback from customers like you, we're launching new capabilities soon. With custom organization policies, we are increasing the expressivity of organization policies so you can define custom constraints based on a wide set of configuration parameters. Capabilities like dry run will evaluate proposed policies against live traffic to better understand the impact of the policy. And finally, you will be able to see resources that violate custom organization policies in Security Command Center. I am super excited to introduce Alex to talk about HSBC's journey in the cloud and in using organization policies as part of being secure in the cloud. HSBC is one of Google Cloud's largest customers, and they've been using it for a long time. They've also been working closely with us in providing early feedback and have been a strong advocate in shaping the direction. So thank you, and Alex, over to you.
Thank you very much for that, Vandy. HSBC is a globally recognizable brand many of you will already be familiar with. HSBC operates in highly regulated environments around the world. One of the things which really stood out to me when I first joined HSBC was the scale of the organization. The GCP journey started around 4 years ago, and today we have over 1,600 projects, and there's lots of other interesting statistics about the platform. We have over 15,000 service accounts managed by HSBC, and we actually create over 22,500 virtual machines per day. To give you an idea, only 2,500 of those exist for more than 24 hours. So we're creating 6.5 million virtual machines every year. We have enabled nearly half of the different org policies available on the platform, and we've done this across all of our projects. We prefer org policies over other preventative controls as they apply no matter where the API call is initiated, whether that's through infrastructure as code, GCP services interacting, or somebody clicking in the UI. And critically, they provide immediate response to the user or system making the call, which reduces violations and rework for people. Before we jump into our journey, I'd like to introduce the themes that you'll see during this talk. What you'll observe is that we have the initial adoption of cloud, then we have detective controls, automated remediation, and preventative controls. And we'll look at how we implemented and improved each of these over time through our adoption. So let's start with 2017. So the environment was manually bootstrapped, and we followed the typical GCP enterprise patterns, such as establishing a shared VPC. Terraform was identified as the automation tool of choice from very early on. Terraform was quickly adopted by the team to manage project provisioning and the management of security-sensitive settings. In 2017, Terraform was built upon a single repository. We used a Perl wrapping script which dynamically generated Terraform configurations, and then there was another Perl wrapper script which actually executed it across all of the projects. But we do refer to this as the dark times for a very good reason. This isn't a pattern that you should try and follow today. From the outset, we established a security and compliance framework, and we developed this using a customized version of Forseti. This data store that backs this product has and continues to be the backbone of our detective controls. In 2018, we also deployed our first organizational policies. As an organisation, we are extremely sensitive to any risks of data loss or security misconfigurations. And these are just a couple of the org policies we implemented very early on. For example, we implemented VM external IP access. This was to ensure that compute instances aren't connected to the internet. We enabled skip default network creation to ensure that misconfigured networks were not created by our users. There's a few other notable policies which we were very interested at when they were released. So for example, the policies which control which compute images can be utilized on the platform, or the policies which control the ability of virtual machines to perform packet forwarding. We also quickly enabled the Cloud SQL public connectivity policies to prohibit public-facing databases, and we enabled uniform bucket level access to ensure proper control of data which is loaded into GCS. So returning back to our timeline in 2018, we also started to see a significant increase in the number of detective policies we required as an organisation. This led us to look towards industry standards such as CIS so that we could undertake a structured approach. As the number of policies increased and the adoption of GCP expanded, we saw a significant increase in the number of compliance exceptions developers were needing to respond to. In response to this, we introduced a number of automated remediation or enforcement scripts. A good example of this is the bucket CMEC configuration script. This would automatically remediate any GCS buckets which were incorrectly configured on the platform, rather than raising an alert and requiring manual activities. And this takes us to 2018. Updates on the compliance framework were agreed, and this was primarily around the categorization of violations into one of 3 buckets, each of which had different remediation requirements. And the team also continued to progress with their investment in Terraform. So in this time, they moved to having more regular execution. They still had all of the configuration in a single repository, but they started implementing Terraform modules and using TFVARS files to define the environment. The wrapping script was also replaced with a Python script, which would execute across multiple projects. And we also introduced limited preventative controls. And at this time, we also had our first application go live on the platform. So what did we learn through this early part of the journey? So initial GCP adoption always requires manual activities, whether this is establishing identity, building foundational services such as shared VPCs or other supporting common services, initial network connectivity such as VPNs or uplifting to DIs, and the enablement of high impact security settings like domain restricted sharing, VPC service controls, figuring out how you're going to do proper private Google access configuration in the environment. Don't delay returning to these items and doing them right. So whether this is managing them as code, having robust change processes, as you delay doing this, the environment gets larger and change becomes much more difficult. Another lesson that we learned was around the security framework. Ensuring you have a clearly defined and communicated approach to compliance and security on the platform is critical. The establishment of a clear compliance framework, which all the stakeholders could understand and follow, was by far the most impactful outcome from early on in our journey. It has formed the base upon which the team can describe the security status of the platform to anyone in the business. Then there's the feedback loop as well. So automation was always a priority for us. However, sometimes it can become part of the problem. Where you are abstracting or automating something for your users, it's essential the action completes quickly and provides feedback quickly. Our early journey included developers waiting overnight to see the results of changes, and this wasn't a good experience for them. So this takes us into 2019, and it starts with the implementation of our first automated remediation application. So this is a Python application which automatically resolves violations on the platform. It's distinct from those earlier scripts that I described, which walked the environment looking for resources, because it was driven by the actual compliance violations themselves. Through 2019, Terraform was further developed as well. So we moved from having a single repository to having multiple repositories, one per project. The team invested heavily in creating more Terraform modules, and we switched to using JSON data structures to describe the self-service. The Python wrapping script was also expanded to implement further preventative controls. And the execution of all of this was driven through a GitOps workflow. So this provided much quicker feedback to the developers. And into 2020, we started developing a new automated remediation process based on Cloud Functions and events directly generated onto the platform. This resulted in much quicker remediation times. However, having an assassin running around your platform does bring its own problems with it. You've never seen someone care or fear about a rollout quite so much as when code is literally designed to destroy resources at scale. We also introduced new security reviews for the cloud products at this point as well. This generated significant increases in the number of compliance policies the platform team were expected to develop and manage. This increase in policies highlighted and exasperated an existing problem: alert fatigue. Application teams were experiencing more and more compliance violations just due to the sheer number of requirements which were being pushed upon them. In 2020, we sought feedback from our internal customers regarding their experience with the platform. The number one friction point for projects going live was violation management. This certainly wasn't an unexpected result for the team, and we had to use this to drive changes with our stakeholders. So from this time in our adoption journey, what did we learn? So preventative controls. We shouldn't underestimate the complexity of implementing our own preventative controls. Even the most trivial controls can become excessively complex to evaluate. For example, we needed to control the firewall rules on the platform, and the team opted to expand the existing self-service tooling, Python scripts, and Terraform to enable this. But really what this required was creating a new Terraform module, which catered for all the configuration requirements teams might have for VPCs, defining new JSON structures in the self-service Git repos, creating code which would parse them and evaluate whether they met the control requirements. I mean, this is complex in itself. Then we had to migrate all the existing firewall rules into the new system, and then educate everybody on how all of this worked. When we started our journey, many of the industry-leading controls we now take for granted were not available. We didn't have things like VPC service controls, restricted API endpoints, domain-restricted sharing, or uniform bucket-level access. They just didn't exist. So many of the challenges which we had to solve with Terraform abstractions aren't your problems anymore. So always look at the platform capabilities before you start solving issues with code yourselves. And then remediation. So as an organization, we had a number of specific controls which we required automated remediation for. Some because they were essential to our security posture, such as immediately destroying any compute instances with external IP addresses. Others because they were easy for developers to neglect, such as the GCS CMEC issue that we mentioned earlier. It is essential automated remediation tooling that you create is simple and predictable, as you're going to be applying it at scale. And talking of scale, there's the controls. So as you enable more products and as the maturity of your security stance improves, the number of compliance policies and things you're going to want to track will increase rapidly. To give you an idea of scale, for GKE alone, we have 80 controls identified by our cybersecurity team. So this brings us to today. So this year we've reviewed cloud security posture management tooling, CSPM solutions. These purport to provide a single pane of glass across multiple CSPs. And it was really appealing for our cybersecurity teams. But there were significant challenges and shortcomings to this, which led to the decision to continue to adopt our native security technologies. We continue to work with the organization policy product team, and some real life examples of the challenges we've shared include the previously discussed requirements to ban specific ports from firewall rules. Today, we have a detective policy. We've done a lot of engineering to have preventative controls. What we really want is a preventative org policy. So we don't require this level of abstraction, and we can safely allow native access to the platform. Next, we also shared GCE instances created without CMEC. Today, we have scripts which remediate GCS buckets which aren't configured correctly, but you can't remediate GCE instances. They must be destroyed and recreated. So this policy is a really good example of how it will stop rework from our developers when they do create instances incorrectly. So to summarize, from this past year, abstractions such as those we've created with Terraform might be necessary for you too, but they are problematic. They're effective for interactions which use them, but you do have to consider all the other way changes may occur on the cloud platform, which don't go through these abstractions. How are you going to manage those? We intend to continue to drive preventative controls using native capabilities And we are very excited about custom org policies as being a key part of this. You should always look to the platform features and tools to support your compliance requirements first. There are so many capabilities now. The org policy list goes onto multiple pages, and product features such as hierarchical firewall policies, which allow you to apply baseline firewall rules, VPCSE secure data exchange, which makes perimeters much more manageable and removes the need for many bridges, and Private Service Connect, which enables you to use small and non-routable networks without all of the overhead of dual-homed instances. And the final thing is to consider how you're going to test your org policies and controls that you're going to deploy. So you need to think about how you're going to structure your hierarchy to support the implementation and testing of these over time. This is a really challenging space, and tags, as Vandy shared earlier, do give us much more flexibility with how we're going to manage this going forwards. So, to summarize, what does the future look like? We're very much looking forward to custom org policies and enabling the implementation of real-time preventative controls. We're hopeful this is going to allow us to reverse the tide on some of the unnecessary abstractions we've had to implement and enable safe consumption of the native APIs. And we do see this as a critical part of our security story. Tags, as described by Vandy earlier, are also critical in that they will enable us to target and safely roll out changes to org policies. Managing org policies has been quite challenging in the past. In this talk, we have focused very much on org policies. However, there are a lot of other native capabilities which, when used, provide a plethora of benefits. These include not needing to compromise your perimeter to implement agent-based tooling on IaaS instances. You can avoid data having to leave your organization, and often these have much lower integration and management costs. And finally, to summarize and close, the key takeaway is that organizational policies enable us to be confident a control is consistently and safely enforced on the platform, regardless of how the interaction with that platform occurs. And now I'll hand it back to Vandy to close us out, and thank you.
Thank you so much for sharing all of that, Alex. We are super excited about customers like HSBC who are leveraging organization policies to build a strong security posture. By using capabilities like organization policies, you can ensure developer productivity without compromising security. And once again, thank you so much, Alex, and thank you all for joining us today.